everyone, myself Akash Mitra. Today I am going to make another video in my YouTube channel to check whether it's a prime number or composite number. For example, 2, 3, 5, 7, 11. These all are prime numbers and which are divided by 1 and by itself. But the composite numbers are those numbers as we already know from our childhood, that 4, 6 which are divided by themselves and 1 and even by any other number. Those are composite number, like 6 divided by 6, divided by 1 and divided by 3 also, where remainder comes 0. So before going any further, let's start our code. As you can see, as I have already written my code, where our C code always starts with include stdio.io.h has standard input output.h means header file, where our printf mechanisms, scanf mechanisms are defined. So, and as we already know, our C codes run in main function. So int main, inside this main function I have defined my code, and returning anything inside main function means termination of program. So first of all, I have done the variable declaration num comma I means iteration or counting or counter. We can give anything num. It will be taken as an user input, and our user input will be in infinite iteration, means as much as we want to give our user input num and check whether it's prime or composite as much as we want, as much as time we want, until or unless we put -1, because in our while iteration number is not equals to -1. I have given this condition because in such case, if I give here in this num value -1 at any cost, then it will break the loop and get out of this while loop or iteration. But if I give other than -1, it will always check whether it's a prime number or a composite number. So let's get started. This is taking an user input. This will be printed in our console as in printf, based on printf mechanism, where this is the argument, as you already know in functions. If number is equals to 1, number is neither prime nor composite. As you already know, 1 is divided by 1 only, and no other such number, means every number is divided by 1 or by itself, but this is 1, so it's neither prime nor composite. And num equals to 2. 2 is always and only even prime number, as you already know. 2 is divided by 2 and 1 itself, but other such even numbers are always divided by 2. So that's the reason 2 is the only such even prime number, only prime number in our numbers, in our series of numbers. So this is a decision. Here I have num equals to 1 means given in if decision making body, then else if decision making body I have given num equals to 2, where equals to the relational operator, num is the operands, 2 is the operands. We check if those two conditions become true, then this will print this statement in a console. And now I'll have to come to our main part of else. Now listen carefully what I have done. For I equals to 2, I have initialized from 2, because as you already know, every number is divided by 1, so initialized with 2, and I should be less than num, means I can go up to I equals to num -1, and I have done this incrementation here. You can do it in here also, it's your choice. So now if num modulus I means equals to 0, if num divided by I means from 2 to num -1, within this range any number is, if divides num and gives a result 0 as a remainder, then it's a composite number. It's a composite number, point to be noted. And if it's composite number, then it will break this for loop, and then this will break this for loop and go for this loop. Okay, if suppose 12, if I have given a user input 12, then I equals to 2. 2 will always divides 12 and gives a remainder 0. So it will, at that moment when I equals to 2, at that moment that this condition satisfies. This means this decision making body satisfies. This decision making body satisfies and it prints in the console. It's a composite number and breaks the for iteration. When these statements become, decision making statement become true in case of 12, and then at that time it will do this will, at that time this will print this portion, and then checks num whether num equals to I or not. Supposedly if I put 12, then I equals to 2 only. In that initialization part only our for loop gets terminated. So num if 12 equals to I is obviously a false statement, and decision making body becomes false. That's why it will not print this number. And then as it's an infinite loop, so it will again check this thing which is not equals to, and again asks for enter a integer type number, means scanf num, until or unless we give -1 as a num to exit this while iteration. As simple as that. Now how it prints this only, not this, I am going to explain it. Suppose if num equals to 13, I have given, then there is 2 to 12, there is means 2 to num minus 1 means 12, 13 minus 1 12, up to that much. There is no such number which can divide our 3. There is no such number which it can divide our 3, and it will be continued in a loop, one after one I plus plus incrementation. It will continue for one after one I plus plus incrementation. When it becomes when I becomes equals to num, this condition becomes false and exit the loop. Then it checks whether num equals to I or not, and obviously in case of 13 num equals to I, 13 equals to 13, then it will print this part, not this part. For as I have already know, from 0 to 12 range there is no such number which can divide 13, so it will go up to 12. And then when it becomes I equals to I plus 1, where I equals to 12 plus 1 means ultimately our result becomes I equals to 13, means I equals to I plus 1. At that time when it becomes 13, and I have given number as 13, which is a prime number because it's divided by 1 and itself only. It's 13 by 13 and 13 by 1 gives us reminder 0. At that time only, when I becomes 13, it exits the loop because this condition becomes false, and check whether it equals to that user input or not, which is actually our num input. And if it's become true, if this decision making statement becomes true, then it prints the rest part of this if statement body, which is this print. And print, it's a prime number in a console, and it will be continued again and again as due to this condition, which says that it's an infinite loop until or unless user gives input -1. If user gives -1, then it will break this iteration and then return our 0 in our main function, and hence the program is terminated. That's it. Now let's run our code and check whether it is perfectly running or not. Okay, let's give 3, which is prime number, giving prime number. 2 is always a prime number. 1 is neither prime nor composite. Now give 8, which is a composite number. 8 composite. 9 composite, because 9 divided by 3. 5 is divided by 5, and 1 divided by itself, so it should be a prime number. Watch, and if I give -1 to break our infinite while means entry control iteration, so then I should give -1. Check, our process is terminated. Execution time this. Okay, up to this much. I hope you enjoyed my video. Thank you so much.